Imagine the night sky suddenly bursting with the brilliance of a billion suns. This isn't science fiction, it's a supernova, the explosive death of a star. These celestial events are among the most powerful and awe-inspiring phenomena in the universe. They signal the end of a star's life and the beginning of something new. For a brief moment, a supernova can outshine an entire galaxy. Ancient astronomers were amazed by these sudden appearances of bright new stars in the sky. Today we have powerful telescopes that can observe supernovae in distant galaxies, giving us a glimpse into the life and death of stars. Supernovae are not only beautiful, they are crucial to our understanding of the universe. They are responsible for creating many of the elements that make up our planet, our bodies, and everything around us. In the vast expanse of space, supernovae are powerful reminders of the constant cycle of creation and destruction that shapes our cosmos. Let's delve into the heart of these cosmic explosions and uncover the secrets they hold. A supernova is essentially a giant explosion that occurs at the end of a star's life. It's like a star's grand finale, a spectacular release of energy that sends shockwaves across the cosmos. These explosions happen when a star runs out of fuel and can no longer support its own weight. This causes the star's core to collapse, releasing an enormous amount of energy in the form of light, heat, and particles. The brightness of a supernova is truly astonishing. Imagine a single star shining as brightly as billions of suns combined. This intense light can be seen from incredibly far distances, allowing astronomers to study these events in detail. But supernovae are more than just bright lights in the sky. They play a vital role in the evolution of galaxies and the universe as a whole. To understand supernovae, we need to start with the life cycle of stars. Stars are born from clouds of gas and dust called nebulae. Gravity pulls this material together, causing it to heat up and eventually ignite nuclear fusion in the core. For most of their lives, stars exist in a state of equilibrium, with the outward pressure from nuclear fusion balancing the inward pull of gravity. This delicate balance can last for millions, billions, or even trillions of years, depending on the star's mass. However, all stars eventually run out of fuel. When this happens, the core can no longer support its own weight and collapses. The outer layers of the star then fall inward, colliding with the core and rebounding outwards in a massive explosion, a supernova. This explosive event disperses the star's outer layers into space, enriching the interstellar medium with heavy elements. These elements will eventually become part of new stars, planets, and even life. Section 4. Different types of supernovae, a tale of two explosions. Not all supernovae are created equal. Astronomers classify them into two main types, Type 1 and Type 2. The difference lies in the way they explode and the stars that create them. Type 1 supernovae occur in binary star systems where two stars orbit each other. One of these stars is a white dwarf, a dense remnant of a sun-like star. The white dwarf pulls material from its companion star, eventually becoming too massive and triggering a runaway nuclear fusion reaction that blows the white dwarf apart. Type 2 supernovae, on the other hand, involve the death of a single massive star. As we learned earlier, these stars exhaust their nuclear fuel and their cores collapse, leading to a massive explosion. Both types of supernovae are incredibly bright and powerful, but they have different light curves, the way their brightness changes over time. Astronomers use these light curves to distinguish between the two types and learn more about the stars that created them. Section 5. Cosmic alchemy. The creation of elements. Supernovae are not just destructive events, they are also cosmic creators. In the intense heat and pressure of a supernova explosion, atoms are smashed together in a process called nuclear fusion. This creates heavier elements that were not present in the star before it exploded. These elements, such as oxygen, carbon, iron, and gold, are scattered throughout space by the supernova's shockwave. Over time, these elements become part of new stars, planets, and even life. In fact, the very elements that make up our bodies, the Earth, and everything around us were forged in the hearts of ancient stars and dispersed throughout the cosmos by supernovae. This makes us all stardust, connected to the universe in a profound way. Supernovae are essential for the chemical enrichment of galaxies. Without them, the universe would be a much less diverse and interesting place.